In the previous lesson, we saw that rational square roots are the square roots of perfect squares. So it follows that irrational square roots are the square roots of numbers that aren't perfect squares. So let's just take a look at the number root 75, and that's how we say that. Root 75. Well, clearly 75 is not a perfect square. It is between the perfect squares 64 and 81. Therefore, 75 is somewhere between the numbers 8 and 9. And since 75 is closer to 81, it's closer to 9. For most purposes, we can use approximations. So we would use this, we would say this line, and we were saying it's approximately 8.7. In fact, in the beginning parts of your homework, you're asked to take square roots and round them to the nearest tenth. If you do take the square root of 75 and you use your calculators for this, it will tell you that it is 8.66 something. So clearly, if I'm rounding to the nearest tenth, that is 8.7. There's also in the world of mathematics a whole way of working with radicals. And another way of thinking about the square root of 75 is to think about what we call simplest radical form. And in a nutshell, just like we learned that the square root of 100 is the same as the square root of 25 times the square root of 4, if we think about the number 75, we want to ask ourselves, does 75 have any perfect squares? And the truth is, it is. It is root 25. I can think of 75 as 25 times 3. And as we have done already with rational square roots, we know that that's the same. I can separate them out. And from there, I can see that this part, the root 25, is rational, and the root 3 is not. So the square root of 75 in simplest radical form is said to be 5 root 3. That's the big idea of how you do all of these. And a lot of things are pretty easy. If I say, oh, I don't know, what is the square root of 2? Well, actually, let's just do the square root of 112. Here's a time where it's really valuable to remember your divisibility rules, especially because 4 is a perfect square. The divisibility rule for 4 is if the last 2 digits are divisible by 4, then that means the whole thing is divisible by 4. So if I want to figure out what this is, I say, actually, you can say 112 divided by 4, and that is 28. So then you know that it's 4 times 28. And then you can see there's still another 4 in there. So 4 times 4 times 7. So this is the square root of 4. This is like the square root of 4 times the square root of 4 times the square root of 7. This is 2. This is 2. And this is 7. So this is 4 root 7. If that's confusing to you, another idea is just to take and let's do the prime factorization of 112. We've already seen that that's 4 times 28. And when I keep going, I've got 2 times 2, 4 times 7, 2 times 2. So I could in the end say the square root of 2 to the 4th power times 7. As we did with the rational square roots, this is a perfect square because it has an even exponent. The square root of it is half of that exponent. So this is like saying 2 squared times the square root of 7, because this 7, can't be simplified. So that's another way to get 4 root 7. in general, you want to take the square roots of any factors that are perfect squares and put them on the outside of the radical. And you want to leave underneath the radical the parts that are irrational. Our irrational parts stay out there, and rational come out here. So you have to be able to sort of figure out what you've got underneath there. Let's just do some. If I say to you the square root of 891, well, most of us don't know at all what 891 might be, what its factors might be, what its perfect square factors. So we're just going to do, actually I'm not going to do it there because it looks like the square root of that. I'm going to go over here. I'm going to say 891. If you do know the divisibility trick for 11, every other digit has to add up to the 1, so 8 plus 1 is 9. So I can see right here that 11 goes into there. And it's 11 times 81. And then from here I can say that's 9 times 9. 3, 3, 3, 3. So I find out that I need to find out, I'm going to do the square root of 3 to the 4th times 11. The square root of 3 to the 4th is 3 squared. The square root of 11 is root 11. So this simplifies to 9 root 11. Sometimes there's already a number in front. For example, if I say 2 times the square root of 24, if I go through this step by step, that's 2 times 4 times 6, because I'm using 4 because it's a perfect square, and that equals 2 times the square root of 4 times the square root of 6, which makes this 2 times 2 times root 6, or 4 root 6. The square root of the 4 comes to the outside, and the square root of the irrational part stays in. If I want to give you steps, the first thing you want to do is find the prime factorization. And after that, use and take the square roots of any roots of perfect squares, and leave square roots, irrational square roots. I'm just going to put it there. So that's all well and good, but sometimes if I get the number, I don't know, let's see, if I say square root of 54, well, that's going to be, I know that 54 is 6 times 9, well, this might not end up being a good example, 2 times 3, oh, this is 3 times 3. So in here I have 2 times 3 to the 3rd. Well, nothing has an even exponent the way we have it right now. However, over here you can see you've got 3 squared in that makeup. So another way of thinking about this is 2 times 3 squared times 3. Now I can take the square root of 3 squared, put it on the outside, that's 3, and on the inside I have 2 times 3, so 3 root 6. What if I have something like 14 root 75? Well, we've already seen that this is 14 times the square root of 25 times the square root of 3. So then this becomes 14 times 5 times root 3. And 14 times 5 is 70. So that's 70 root 3. Let's do one. I'm not really sure if I can find one off the top of my head. Okay, let's say the square root of 48. Well, 48 is 16 times 3 which is 4 times 4, which is 2, 2, 2, 2. Okay, well that's not very helpful because 2 to the 4th, we all know the square root of 2 to the 4th is 2 squared times 3, so that equals 4 root 3. Okay, so I'm going to just start with prime factorization. What if I have one that is 2 to the 3rd times 3 to the 4th times 5 to the 3rd? Well, before I can really take the prime take the square roots, I have to re-express. Actually, this is going to be a really big number. I don't even care what it ends up being. Okay, 2 to the 3rd is the same as 2 squared times 2, right? Because 2 plus 1 is 3. 3 to the 4th, we don't have to worry about. It's got an even exponent. 5 to the 5th is the same as 5 to the 4th times 5. Now I'm ready to take the perfect squares. The square root of 2 squared is 2. The square root of 3 to the 4th is 3 squared. The square root of 5 to the 4th is 5 squared. And then what stays in is 2 times 5, or 10. And that would make this end up equaling 2 times 9 times 25, or 450 root 10. So this just takes practice, but it's a fundamental skill for this entire chapter, so it's important to work at it.